Hello everyone, this is Hidayat Shahid. I'm your lab instructor for MECE2310U Concurrent Engineering and Design course. In this instructional video, I will walk you through Lab 1B exercise, which consists of two parts. In part 1, we will use your hand press that you created with multi-bodies in your Lab 1A. We will use that part file and we will create a working assembly from there. And then we will modify that assembly file. What we will do is we'll create a spring in this assembly. And by using the motion animation tool, which is available in SolidWorks, we will create a realistic animation for the spring mechanism. In part 2, we will review SolidWorks engineering drawings. We will create the assembly drawing first, and then we'll review some drafting for one of the part files which we are providing you in Canvas. To start this exercise, please open up your Lab 1A hand press that you created in your first week for the labs. Please go and save this file as, and please save it in a folder for Lab 1B. So I'm just basically going to create a folder there. So I will save this file with your student ID Lab 1B. So all the parts and components and everything assembly, I will be saving it in this folder, and I will save this one as Lab 1B, and I will call it hand press, for example. And this is a solid part. So I have saved that. Now what I'm going to do is I'm going to review my part file. In here, in the feature manager, I notice here under solid bodies, I have 3 bodies. The first solid body is this handle, the second one is the pin, and then the third one is the fillet. So fillet includes this rod and everything, and this is got merged together. This rod got merged together with my frame when I created this V feature. And I'm sure in one of these steps you may have done the same thing. So before we start doing the assembly, we're going to make some modifications. Now to start, I'm going to review my hand press that I created for Lab 1A. My hand press will be slightly different than yours because I have been using this file to do a couple of things. So some of the names for individual components may show up, may differ from what you will see on your screen. Having said that, the first thing that I'm going to review is the solid bodies in the feature manager. By expanding it, I can see there is this boss extrude solid body which is associated with this handle, and then there is a solid body is associated with this pin, and then there is this fillet 10 which is associated with this frame. When I created this part model, when I created the sweep feature, I ended up merging my rod with this the frame. So you may have done the same thing. It all depends is one selection. So I'm gonna show you how to create the 4 bodies from here. If you already have 4 bodies and your sweep feature did not merge together with this rod, you're fine. So you can skip a couple of first steps in the lab manual. Okay, now what I'm going to do is I'm going to save this rod as a separate body, which got merged together with the sweep feature. To fix that, I need to go to my sweep feature, and I'm going to right click on it, and I'm going to click on Edit Feature. And in here, I have this rod, which basically you may have different name. For this one, you may have some extrude number or something like that. So please unselect that. To unselect it, simply click on it and right click and then hit delete. As you can see, this is unselected, and click OK. So now if I review my solid bodies, I have my fourth solid body, which is rod. In your case, the name will be different depending on how you created it. So now I'm going to make some changes to the sweep feature dimensions. The first change that I'm going to make is I'm going to click on the sketch after expanding the sweep feature. I'm going to right click on it. I'm going to click on edit sketch. I'm going to change the circle diameter to 18 millimeters and I'm going to exit the sketch. So it will reduce the diameter for that. And the next modification I'm going to make is I'm going to right click on the path profile for the sweep feature. I'm going to make some changes to the dimensions. And the first dimension that I'm going to make change to is it's all the way over here. I'm going to change this one as 0.1 and I'm going to change this one as 67 millimeters. And I'm going to click OK and I'm going to exit the sketch. So as you can see, this support has been modified. And the next step that I'm going to do is I'm going to change the size for this. I'm going to make some clearance for this frame between this and between the frame and the and the rod. To do that, I'm going to select this face and I'm going to look normal to, and then basically I'm going to click on sketch tab and I'm going to click on sketch icon and I'm going to position it coincident with the whole center point, and I'm going to draw a 2D circle. And the dimension for this one, I'm going to simply specify as 23 millimeters. And after I have created the sketch, I'm going to go to Features tab and I'm going to click on Extruded Cut. And in the Extruded Cut, Cut Extrude dialog, I'm going to specify the depth. I'm going to leave the direction as shown below downwards, and the depth I'm going to set as, like, let's suppose 123 millimeters. And under feature scope, I'm going to unselect this auto select, and in here I'm simply going to select this frame. Okay, base or whatever name in your case would be, just select that and click OK. So basically what it has done is it has just basically cleaned up and it had created some sort of clearance in there. Okay, so this is done. After this, it's always a good practice to save your work frequently. And now what I'm going to do is I'm going to create a feature on this cylinder. So to do that, what I'm going to do is I'm going to select this face and I'm going to click on Sketch tab and I'm going to click on Sketch icon and I'm going to add a 2D circle there, and I'm going to just position it right at the center so that it's concentric with that. In the smart dimension, I'm going to specify as 30 millimeters. The sketch is fully defined. And now after creating this, I'm going to click on Features tab and I'm going to click on Extruded Boss Face icon, and after it's done, in the method, in the dialog box, I'm going to specify as offset, and in here I'm going to set it as 5 millimeters, and the direction I'm going to change it towards the opposite direction, which is currently shown in the preview. I'm going to click that, so that's done from there. And for the In here, I'm going to set for direction blind, and the depth for that one, I'm going to set as 5 millimeters. Okay, under the feature scope, please make sure only use the selected bodies, uncheck this auto select checkbox, and then basically only select this rod. Okay, so this is important, and click OK. So after this is done, a ring is added, which will be used to position the spring at the bottom. In real life, the assembly will work slightly different. You will want to add a spring on the top, because if that's where you want to do the compression. But this is just for the to introduce you to the animation feature associated with this spring. So now, if I review my solid bodies, I have 4 solid bodies. Okay, now I'm ready to create the assembly from these bodies. Before doing that, I'm gonna make one quick change here, which will be slightly different than your laminal. Again, I'm gonna rename these bodies as this one will be sliding rod. I'm gonna name this file, this body as sliding rod. You can save this one as base frame, and this one would be handle, and you can put your student ID right in there. And this one will be pen. Okay, so I have done that. Now I'm gonna split these bodies and save them as individual components, and I'm gonna create an assembly from it. To do that, I'm gonna right click on solid bodies, and I'm gonna select save bodies from there, and I'm gonna check mark these boxes, check boxes there, and I'm gonna click for the assembly, lab 1B student ID hand press, for example. And I'm gonna click save. Yeah, it does this weird thing, but you can always go back and select that again, so it will save everything in that folder. And I'm saving everything in the folder that I have specified. I'm gonna click OK, and it's gonna basically you can click yes to that. It's associated with the units, and I'm gonna click rebuild and save the document. So this is the solid part that you have, and then this is the assembly that has been created based on those parts. So if you review this, you will notice these parts, these are different components have been created in your assembly. One thing you will notice, everything is fixed in here, so nothing would work as you intend. And in the mates, you will not notice any mates in there. So basically, it has used the configuration of the part, and it has basically positioned the components as they were specified in the part modeling environment. So now I'm going to make changes to this assembly so we can have it making into a working model. Before I do anything, I'm going to change the units to mmgs, and I'm going to click save, and I'm going to select save all. And in here, the handle, I'm going to select handle, and I'm going to press control key. I'm going to select sliding rod, and I'm going to select pen, and I'm going to make them float. By right clicking on it, I'm going to set them as float. Now, if I move this, this is moving around. Since there is no mate, so there is no positioning, and that's what basically it is. And now I will add some mates so that the assembly can be completed. So the first mate I'm going to add is the sequence of the assembly may be slightly different in the lab manual, but at the end the assembly would be the same. So I'm just going to quickly go ahead and then complete the assembly. I'm going to click on mate icon from the assembly command manager, and I'm going to select this. serve face, and I'm going to select this face, and I'm going to make them concentric. Okay, and the next I'm going to do is I'm going to select this face, and I'm going to select this face, and I'm going to make it coincident. That's what it's called in the lab manual. But you could add a distance so that it's equally positioned for the purpose of the lab. Don't worry about it. You can just make it coincident to make the assembly a little bit more faster. So this is fixed. The next one, I'm going to add the mate between this face, and I'm going to select this face, and I'm going to make them concentric. And I'm going to select this face, for example, and I'm going to select this face, and I'm going to add a distance mate between the two. And the distance mate, I'm just going to pick, for example, 0.01 millimeters, just for the positioning. So I'm going to select OK. And so the handle is positioned, and the next mate I'm going to add is between this face, and I'm going to make them concentric. And I'm going to move it down like that. And now what I'm going to do is I'm going to exit this mate dialog. Now I'm going to modify this rod. To do that, what I'm going to do is right click on this rod, either from the feature manager or directly from the part, and click on open parts part in the position. So this will open up this part. I'm going to add a fillet on this edge. To do that, I'm going to click on fillet icon, and I'm going to select this, and under the radius for this fillet, I'm going to select set as 10 millimeters, and I'm going to click OK. So this is created. I'm going to save this file, and I'm going to close it. And this is associated with the assembly. I'm going to say yes. So that will update this assembly, and I'm going to save this assembly. And I'm going to add a tangent mate. To add the tangent mate, I'm going to move, I have moved this rod up so they're like, close to each other. And then I'm going to click on mate, and I'm going to select this face, and I'm going to select this face, and I'm going to make them tangent to each other. And I'm going to exit mate. So now if I move my handle up and down, so basically it moves the sliding rod. So this is done. And one thing, my assembly right now looks like it's same color and so on and so forth. I could add materials to it by simply going to the part individual components, and I could assign materials there that will change the color. But I'm just simply going to change the appearance for different components. To do that, for example, I'm going to select this handle, and I'm going to click on this appearance, and I'm going to change the color. And I'm going to simply select blue, for example, here. Select OK. And I'm going to do the same thing for pen. I'm going to change the appearance for that. And I'm going to make it, for example, this is the frame I have selected. I will just make it a little bit look better. For example, this is the color I selected. I'm going to select this pin now, and I'm going to change this appearance for this pin, and I'm going to set it as black, for example. And the rod, I'm just going to leave it as is. So this kind of distinguishes the colors. So now in the next step, what I'm going to do is I'm going to add a spring. How do we do that? We're going to add the spring in the assembly environment. To add a part, we simply go to Insert, Components, and select New Part. So this one basically will create a new part in your assembly, which is shown here. So as soon as that's done, just double click on it and change the name to, I'm just going to slide in here. Okay. spring. Okay, so I have changed the name to spring, and then we're gonna create that part by using the features on this external features on the other components. Now I'm going to add the spring part. I'm going to define it. To do that, I'm going to go to Feature Manager, right click on the spring part, and then click on this Edit Part icon. And in here, in the Sketch tab, I'm going to click on Sketch. And for the sketch plane, I'm going to specify this face. And I'm going to click on this Convert Entities. This is reference external to the rod part, sliding rod, and basically I'm going to select this edge and I'm going to click OK. So this is going to create the sketch, and then I'm basically going to exit the sketch. So I have the sketch created, which is shown here, and now I'm going to do the same thing on the other side, right here. To do that, again, I'm going to click on sketch, and I'm going to select this face, and then I'm going to select this Convert Entities, and I'm going to select this edge, and I'm going to click OK. So as you can see, this has created a sketch here. So now I'm going to use this sketches to define the spring profile as well as the path. To do that, what I'm going to do is I'm going to select this plane, and I'm going to look normal too, and I'm going to keep it selected, and I'm going to zoom in, and I'm going to just make this plane a bit bigger so that they're kind of out of the way, and I'm going to click on the sketch, and while I'm in the sketch mode, I'm going to select this circle tool, and I'm going to browse here. I'm going to make sure that I'm coincident with that edge that where I have created the sketch, and I'm going to drop this circle there, and I'm going to click on Smart Dimensions, and I'm going to set the diameter for this circle as I have just noticed I am working in the inches, so for your assembly, please make sure you change the working units to millimeters so that everything will be consistent. And I'm going to go back to my sketch that I was working on, and I'm going to click on Edit. And the diameter for this circle, it's supposed to be 2 millimeters. And the position of this center point, of this center point, is supposed to be 14 millimeters. To do that, I'm gonna basically gonna pick the center, and I'm gonna select this. This can be tricky sometime. I'm just gonna rotate it so it's easier for me to line things up. I'm gonna select this, and I'm gonna select this center point. Okay. Yeah, there we go. So this one needs to be 14 millimeters, and that will fully define the sketch. Okay, so I have created that, and I am going to exit dimension, and I'm going to exit sketch. And now I'm going to create on the front plane. I'm going to select front plane again, and I'm going to create another sketch. That sketch will be simply a straight line, which needs to coincide with this face and this face. So I'm gonna basically start from there. So as soon as I am coincident, and I am coincident there, that's where I'm gonna stop. And the sketch is fully defined. So basically that's the profile. That's how I'm gonna I'm referencing the parameters for the spring. So I'm gonna exit the sketch, and now I have a few sketches around there which I will use. Now after you have done that, I'm gonna go to Features tab. I'm gonna select Swift Boss Base, and in here the parameters that need to be set is basically leave as a sketch profile, and for the profile, select this. For the sketch, select this path, and for the options, expand the options. Under here, specify follow path, and profile twist under in here. Specify the twist value, and under here, twist control set as revolutions, and number of revolutions set as 7. So this will give you the preview, and click OK. So now I have added the spring. But if you notice, if you zoom in, this spring is going through this part. So I'm going to basically chop off the material from there so that it is flat against this face and on the top face. To do that, simply I'm going to select this extruded cut, and I'm going to select this edge, and I'm going to change the parameter here. I'm simply going to specify 1 millimeters, and I'm going to click OK. So basically, as you can see, it has chopped off the extra material, and I'm going to repeat the same thing on the other side. And I'm going to click on the extruded cut, and I'm going to select this one. And the direction, I'm going to keep it that way. I'm going to click OK. So as you can see, it has flattened the face. So this basically has created the spring. After you have done it, simply exit the edit component, and the spring is there. So once the spring is there, just please make sure that this spring is not fixed. You can always make it float there. If it was fixed, then things will not work properly. So make sure the spring is floating. So now if I move my handle up and down, as you can see, the spring doesn't move with the rod. And if I move this one basically down, it's going through. So the spring is not behaving as a spring in real life. For sometimes in your presentation, you want to simulate your system or your mechanism and so on and so forth. So for the purpose of this lab, we want to make sure we want to create a video which we can integrate in our presentation, where the spring should be acting as spring. So now we will do that. Before doing that, I'm going to save my file with the rebuilding, and I'm going to save the components internally. And I'm gonna to create the animation for the spring or the motion study. I'm gonna click on this motion study. In here, I'm gonna leave this one as the type of study as animation, and you will learn about this motion study in your next few labs. So in here, the first thing what I'm gonna do is I'm gonna right click on this orientation camera, and I'm gonna disable the playback. Okay, and now I'm gonna define my motion parameters. To do that, I'm gonna click on from the motion manager tools. I'm gonna click on motion study properties, and I'm gonna set the animation speed as 90 frames per second. This basically, when you create a video or the animations, it provides smooth animations. After I have done that, and now basically you click on this handle, you select it, and now you're going to add a motor. And motor will simulate up and down movement associated with this spring. So in this case, we're going to create a rotary motor. And for the component direction, I'm simply going to select this edge, and I'm gonna change the dimension, the direction the other way. And under the motion parameters, I'm gonna specify um, oscillating, and for the oscillation, we're gonna specify 40 degrees. So it's gonna move back and forth with the 40 degrees, and starting angle, I'm gonna keep it at 0 degrees. Under the component, I'm going to select this handle. So this is selected. I'm going to click OK. So the motor parameters have been defined. Now I'm going to solve for the motion animation. To do that, I'm going to click on this calculate icon, and I'm simply going to wait until the motion parameters are solved. And you wait as well while it's calculating the motion parameters for the animation. If you don't have the motion study tab available on your SolidWorks interface, you can always go into the SolidWorks add-ins, and you can click from there and then add in the motion SolidWorks motion add-in. I'm just waiting, and that's where the um, speed of your computer is critical. So my solution is complete, and I'm basically going to move this back, and I'm going to click on play. As you can see, my handle is moving from 0 to 40 degrees, and the spring is working as a spring will work in real life. I'm going to play it one more time. So there we go. And now what you want to do is you want to show this in your presentation and so on and so forth. I'm going to show you how to save this animation in as a video. To do that, you click on this save animation icon, and you can change it the type of video file that you want to export. I'm simply going to say MP4 video file, and I'm going to save in the same folder. Please make sure you save this video file in your folder. That will be verified when we are marking, and the frames per second you can leave at 7.5. So basically now it's exporting the video file, and I'm just gonna wait till that and so that video file has been exported, and I'm gonna save this file so that all the motion animation is saved as well. Okay, now it's done. And now I'm going to go back to the model tab, and I'm going to create the assembly drawing from this for this assembly. To do that, I'm going to simply go to file, and I'm going to click on make drawing from assembly. And in the dialog box here, I'm going to select A3NC. And I'm going to click OK. And first thing first, I'm going to change the units to mmgs as usual. And I'm going to click on the view palette, and I'm going to bring in the couple of views that I want to bring in. For example, I'm going to click on this top view, and I'm going to drag it on the sheet, and I'm gonna just simply move my mouse down, and I'm gonna drop the other view there. Okay, and I'm gonna click OK, and now I'm gonna bring an isometric view from the view palette. I'm gonna simply select this and drop it there, and in the display state, I'm gonna select this one as shaded, and I'm gonna click OK. Okay, the scale for the sheet, you can change it if you wish, but I'm gonna keep it as 1:4. And now I'm gonna show you how to create the bill of material. To create the bill of material, you go to Annotation tab, and you click on this table and expand um, and click on Bill of Material. And in the dialog box, you specify this isometric view, and then basically click OK, and then you drop the bill of material wherever you want. And if the spring was not created, you could manually add that component as well by modifying the bill of material, and you can resize to fit or provide the descriptions if you wish. And now I'm going to create identify these components by adding some balloons. To do that, you go to the annotations and you click on auto balloon, and then I'm not going to select it. Select this view and auto balloon, and click OK. So basically, the now we have the full description of individual components, and you can change this the positions and for individual components as you wish. And you click OK on that. So this is basically shows you how to create bill of material for your assemblies. And now, for the purpose of this lab exercise, please make sure you save this drawing in the same folder that you have been working. And I'm going to leave it as your student ID hand press drawing, and that's it. So this completes your exercise associated with this hand press. And now I will move on to the next part 2, where we will review some of the fundamentals associated with the SOLIDWORKS engineering drawings. To complete part 2 associated with this lab 1B exercise, you're going to need one of the file which is uploaded on Canvas. Please download this file, which is named as lab 1B underscore part, and save it in your lab 1B folder. And then double click on this file and open it. I have already opened this file to save some time for the video. So this is the file that the part CAD model has been provided to you. So now this will be used to review some of the drawing and drafting tools in SOLIDWORKS. So we'll create a drawing from this part. You can have a look at how from the feature manager, it basically walks you through how this was created with the different features were added. So basically you can have a look there. Circular pattern was created, and then some planes were added, which you can see how the planes were added by simply right clicking and looking at the edit feature, how these reference planes were added. As you recall, the planes can be inserted from insert menu, and then basically under reference geometry you could add in a number of things as you wish. But for the purpose of this exercise, I won't go into details for that. So I will basically start making a drawing. To do that, you go to File, you simply select Make Drawing from Part, and it will open the dialog box. From there, select A4 NC Landscape. That's what you will select. And under here, simply go and change the units to mmgs. The document properties for this engineering drawing you can select under options, and the scales and other things you can specify accordingly. And these steps are described in your lab manual in details. So the first thing first, what we will do is we will maintain um, the size, and we're gonna drop and drag in a couple of views. To place the drawing view, all you gotta do is simply go to the view palette and click on the view that you want to bring into your engineering sheet. Simply drag and drop, and then you move your mouse. It will bring in the projected view for that. Okay, so that basically is done. And from there, you can add other views as well. What I'm going to do is basically I'm going to continue to add a couple of views. For example, I'm going to add in the isometric view in here. And for the isometric view, I'm going to select the display style as shaded with edges, similar as the assembly. Now we can just like simply move, select the views, and then reposition them as we want. And for this part, if you notice here, there's two holes here which are not deep. Sometimes if the parts are complicated and you want to reveal the internal features, you can add the section view. In this lab exercise, we're just walking through those steps. To add a section view, all you simply got to do is go to view layout, and from here there's a number of options are available: breakout view, broken out section. There's many other options are available. So for the lab exercise, you need a section view. To do that, you simply click on this section view icon, and then you select the horizontal line, and then basically where you want to place the section view, you move your mouse. I am going to basically select this point, and I'm going to click OK. So basically now it is cutting the part, and and it's revealing the view. If you cut this part into half section, whatever view that you will see, if you not look normal to it, that view has been placed. And the directions, the cut direction can be changed for the section view, but I'm going to simply click OK. So these arrow points which direction you're looking at it. The lab manual itself, it requires you to place um, make some changes to the document properties, so on and so forth. And in this step, that's what I'm gonna walk you through. There's a number of things that you can change. So when you work in the industry, normally when you create your drawings, you will adhere to their standards. So whatever format, whatever the standard they have in place, you will simply follow them. So SolidWorks engineering drawing, it provides you a lot of options, a lot of styles you can use to describe your engineering drawings. And those can be accessed under option. You just simply click on this icon. And then in here under the document properties, you can specify various aspects associated with your engineering drawing. For example, in here, as for drafting standards, you can set whatever the standard your organization is using. I'm going to leave this one as ANSI. And under units, it's MMGS, which can be set from here as well. And in terms of dimensions, you can specify what kind of precision you would like, and also the arrow style, and so on and so forth. So for this lab exercise, I'm just going to simply use primary precision as none. And there's a number of other items that you can modify, which are specified in your lab manual. So now I'm going to quickly go over them, what you're supposed to do. For example, in their dimensions, you can change the chamfer, and you can set the style as horizontal underline text. You can basically select one of those, or you want to have it horizontal text along model extension. I'm simply going to select this. Okay. For diameter, I want to have the broken letter horizontal text. For a whole callout, I'm going to have the same thing. For radius, I want to have the same thing. And for the angles, I'm going to go with, for example, this one, broken letter horizontal text. And to apply the setting, you simply click OK. So those will be taken into consideration when the dimensions are placed. So now I will add a couple of annotations. I will start adding some of the dimensions which are prescribed in your lab manual. For example, before adding some dimensions, I will just adjust these views a little bit so that I have a little bit more space to place the dimensions. To place the dimensions for this one, we want to go to Annotations and simply click on Smart Dimensions and point to, for example, this hole. This is the dimension I want to specify. I could simply drop it there. And in the next dimension here, I'm going to simply select this and I'm going to drop it somewhere there. And you can reposition these dimensions to make your drawings um, uh, more organized and easy to understand. And there should be uh, uh, there should be no confusions. And now I'm going to specify the I'm going to select, for example, what I want to do is I'm going to just zoom in. I'm going to click on Smart Dimension, and I'm simply going to drop it there. When you're placing dimensions, just make sure that your dimensions are not crossing over and they're easy to understand. And also the dimension, you want to place it in a position which is the most descriptive of view. So the next dimension, what I'm going to add is now I'm going to basically add linear dimension, and I'm going to select this edge and I'm going to click on this edge, and it will read in the inferred dimension there. I'm going to drop it in there, and I'm going to specify the position of these holes with relative to each other, which is I'm going to simply drop it there. And the last dimension I'm going to add is for the center to center distance between these two holes. One here, and this is basically, I'm going to drop it somewhere there, 100. So when you're putting your dimensions on your drawing, you want to put them at a consistent distance from each other. And also you want to put your labels in the middle normally, or whatever your conventions or the standards that you're using in your organization. So I'm going to leave this one here to just get a little bit more space. I'm simply going to move this one here. And I'm going to add a couple of dimensions on the this view. And to do that, I'm going to click on Smart Dimension, and I'm going to select this horizontal line, and I'm going to select this horizontal line, and right in the middle, I'm going to drop this dimension. And now I'm going to select this line and this line, and I'm going to drop this dimension somewhere there, kind of this. All right, so these are the dimensions I have added, and now I'm going to add some dimensions on the section A view. To do that, I'm going to basically create some center lines in this view first. To do that, you basically go to Annotation tab. I'm going to exit the Smart Dimension. First, Annotation tab, I'm going to select Center Line. And in here, I'm going to select this view. I'm going to do the auto insert, and then basically it adds the center lines everywhere where they're needed, and I'm going to click OK. So these are added, and this one I could drag and drop there too, and basically reposition it. And after the center lines are added, there's a couple of dimensions that you are required to add in this lab exercise. So to define this part completely. Again, I'm just gonna move this one a little bit higher, and this one I'm gonna move it a little lower so that I have a little bit more space to place the dimension. And I'm gonna click on the smart dimension again. And from there, I'm gonna add some dimensions. The first dimension that I'm gonna add is I'm gonna zoom in. I'm gonna select this point, and I'm gonna select this point, and I'm gonna add this dimension, and I'm gonna drop it somewhere there. And I'm gonna click OK. Smart dimension again. For this one, I'm gonna add the dimension for this. I'm gonna select this line, and I'm gonna drop this dimension somewhere there. Okay, and I'm gonna drag this one up a bit so that it's out of the center line. So this is added, and now I'm gonna select this edge and this edge, and I'm gonna drop the dimension somewhere there. And now I'm gonna add the angular dimension. For this one, I'm gonna select, and I'm gonna select this one, and it will show the angle like that, or I could simply drop it somewhere there or reposition it to look better. And click OK, and I'm gonna zoom out. So basically this one is added. So these are the dimensions which are needed or which are specified in your lab exercise. Now we're gonna make some changes. We know there's number of holes which are repeated, so we're gonna add modify these dimensions to show that, to implement that in the this drawing. Okay, so the next thing what I'm going to do is I'm going to click on this dimension, and in here we can modify the text. And basically we know there is a total 3, 3, 6, 8 holes. So basically we're going to do is specify 8x, and since this is a through hole, we could simply type through all, and we could enter so it fits better, and click OK, and we will bring it down so it doesn't touch the border. And now as you can see, these dimensions seem to be a little bit touching each other, so I'm just basically going to reposition it a bit so that they have some distance between them, so they're not hard to read. And also for this lab exercise, if I had to do this, I will be cleaning this engineering sheet as well. So the next thing what we want to do is, we don't know, we have if somebody reads this drawing, they would not know the depth of these two holes, so we're going to add that as well to this engineering drawing. And to do that, all you got to do is simply basically select this, and then under here you want to add, because there are two holes, you add 2x, and under here you enter, and then you specify the depth of that hole, and I'm gonna click OK, but it has not picked up the depth, and I'm gonna manually enter that depth, which is 15 millimeters. So I'm simply gonna enter 15 there, and click OK. All right, so this is done, and unless otherwise specified, if I will go zoom in into this sheet, it is showing the unless otherwise specified dimensions are in millimeters, so I don't need to add the note. And this is where the design for your sheet, you can specify general notes and so on and so forth. The depth is specified. So this basically more or less completes your lab 1B exercise. Please save this file in the same folder where your part file is saved if you don't save it there, and please make sure you save this engineering drawing with the name with your student ID. So this will complete your lab exercise. Thank you very much for watching this video.